and then 80 minus 23, the natural log of 1 plus 0. Because you're plugging a 0 in, the initial amount happens when time is 0. And then he said back here, this gives you negative 23 times the natural log of 1. And without using your calculator, because it's not necessary for this problem, this part back here becomes what, Brandon? 0, because the natural log of 1 is 0. That's one of the properties of a log. So the log of any base of 1 is 0. The natural log of 1 is also 0. So the amount of the drug that was administered, because this is 0, 80 minus 0 would be 80. So of this pain drug, pain medicine, we have 80 cc's of the drug that was administered. And that's the initial time. So when it's first getting pumped into the IV. The second question says, how much is present after 2 hours? So 2 hours has gone by. How much remains in the bloodstream? What would you do to find out how much is remaining after 2 hours, Chelsea?
You plug in a 2 for T.
Yeah, so we'll plug in a 2 for T. So now we have 80 minus 23 natural log of 1 plus 2. And if you plug all that in your calculator, this time you actually have to plug it in your calculator because we don't know what the natural log of 3 is. Chelsea, you end up getting
Like that. 54.7.
yeah, 54.73. That's just plugging it in your calculator. 80 minus 23 natural log of 3. You don't have to do anything special there, just plug it all in. Okay, so then the last part is the one that's a little more interesting because it says, discuss how you'd solve algebraically and support graphically the following question. How long will it take until 20 cc's of the drug remain? So now instead of finding an amount of time, we want to find out how long it would take until we have 20 cc's left of the drug. And we could solve for 0 as well. When would it dissipate from your system? So Kate, what are we doing algebraically to find out how long it's going to take when there's 20 cc's left?
I plugged in 24 math.
Yeah, so this is the value you're plugging in for f of t because that's actually the y value. And then we have 80 minus 23 natural log of 1 plus t. It was 23, right? So how do you solve that then, Kate?
And I subtract 2 of the 80 the other side.
So that gives us negative 60. So our goal is to get the natural log part by itself, and then,
Divide by negative 1.
right, divide by negative 23. So if we divide by negative 23, we have 60 23rds is equal to the natural log of 1 plus t. And I caution you not to always try and convert something to a decimal. Keep it as the exact fraction, even though it's not really a nice fraction to look at, it's still exact. The more you round, the less exact your answer is. So just keep it as 60 over 23. It's not hurting you to write it as 60 23rds. After we have the natural log by itself, what do you do next then, Kate?
You convert it to e to the 60 over 23rd equals 1 plus t.
Good. So you've exhausted all the possibilities of working with it as a natural log. You got it by itself, but there's nothing else you can do as it's listed in this form. So we convert this because the natural log really has a base of e. So e to the 60 23rds is equal to 1 plus t, or t would be equal to e to the 60 23rds minus 1. And k, that is approximately
12.581.
So approximately 12.581 hours, a little more than 12 and a half hours, or half a day. So that's the algebraic method process of solving a logarithmic equation, or a natural log equation. The natural log by itself, and then flip it into the other form. Any questions with that process? So, did anybody try and look it up in the calculator yet? What do you think you do if you're trying to find in the calculator when it will reach 20 cc's? So what's one thing you would do, Michael?
Well, I just typed the equation, I got the graph, and then I said the value button, and I typed in what I found for x, and then it came up as like 20.0 something.
So he said, you plug this into the calculator, use the value button, which is under that math function. So that's one option. Another option would be to hit the table button and look up the table of values. And then you can find out like the two x numbers that it's in between. A third option, Virginia? Exactly. And that's going to get you the exact answer. So the third option would be to plug in into y2. You plug in 20. And then you have a horizontal line. So you can find out where they intersect. Because that intersection point is the exact point where it's equal to 20 for y and whatever that x number was, that was 12.581. So you would use then math, and you'd go down to number 5, I think, where it says intersect. Now you'll have to change your window, TRSPC. Any questions? So algebraically, you're trying to get the natural log by itself. Graphically, you can think about it multiple ways, but to get the exact value, you plug in both of these, find that intersection point using that math function. So second trace, then you're going down to intersect. Eris, did you have a question? No, I saw your hand up, I'm sorry. Questions on that? So from your homework, what questions did you want to go over when you're solving equations involving logs and exponents, Virginia? Oh, thanks, Brandon. I got it. See, I was quick. So 109 says, we're dealing with that natural log again. X plus 5 equals the natural log, x minus 1, minus another natural log of x plus 1. So 3 different natural logs. So on the left side, what do you think you'd do with trying to combine the right side? What would you do to try and combine those two natural logs together? Right, so when you're subtracting logs or natural logs, to combine them together, to condense them, subtraction actually can be written as division. So you'd keep the natural log outside, and then you're taking x minus 1 divided by x plus 1. So you can condense those two together into division, and that's another property of logs and natural logs. And then we still have this x plus 5. And this is really now like grouped together. So now we have a natural log on the left and natural log on the right. What else, Eris?
You can like take out the natural logs because it's the same thing on both sides.
Yeah, so because you have the same thing on both sides, they're equivalent, you're really just solving for the pieces next to it. So we have x plus 5 equals x minus 1 over x plus 1. So we got a whole bunch of x's, but at least the natural log is out of the problem. And then how would you solve that, Eris?
You multiply the sides by x plus 1.
Good. Remember, these x's don't magically cancel. The one has a negative one with it, the other one has a positive one with it. They're not the same. But we can take this x plus 1 and multiply it on the other side with the x plus 5. Because then the x plus 1 cancels. It's out of the denominator. And on the other side, Eris, we have
X squared plus 6x plus 5.
so now it's in more of that horizontal format. We no longer have a fraction in the problem. We have this horizontal line. So setting this equal to 0, zero product property says if you want to solve for x and you have quadratics, gotta set it equal to 0. So we would take the x to the other side, which now means we have 5x. We'd also take the 1 to the other side, which means we would add it, so that gives us 6. And your favorite thing to do, Chelsea, of course, would be
Oh, yeah,
factoring. And this factors as
x plus 3, x plus 2.
right, x plus 3 and x plus 2. So your solutions are -3 and -2. But what's wrong, Brandon?
You can't do that.
Why not?
You can't take the natural log of the negative number.
Yeah, so if you go back to the original problem, yes, we found x, but the original problem was starting with natural logs. And if you plug a -2 or a -3 in here and in here, you're going to take the natural log of a negative number.
I skipped all of that. I don't know if I did this right, but I kept the natural logs and I did e natural log x minus 1 divided by x plus 1 equals x plus 5. So, and then the calculator just said no solutions.
What word would I not like in your sentence there?
I wasn't paying attention.
What did you just say? The blank said no solutions.
The calculator.
You don't need a calculator for this.
Well, I wanted to keep the logs in and I skipped all of that.
Yeah, so that the calculator did all of that for you.
Yes, exactly.
Exactly. Might have to kick you out, Brandon. I was thinking I was liking you this year, but
You never said we couldn't use our calculators for 109, so I did.
the only one you were using it for was 123.
Never specifically said.
Okay, so excluding Brandon, is everybody good with this problem? Not gonna look at you anymore, Brandon. So we're gonna solve a couple of applications today. It's the last page in your notes. It's pretty straightforward. Brandon.
I was just trying to solve e and the natural log of the x minus 1, x plus 1, and then I would have taken that answer, and then I would have subtracted 5. But it wouldn't give you that answer, so no solution. I think that's really wrong. I think I just got lucky.
So, a little bit of notes today. Bless you. Allergies or cold? Yeah. Last year we talked about compounding interest. That was one of the applications that we could use natural logs or the natural number e and the exponent, two different formulas for. When you're compounding interest, that means the bank, if you're investing money, is giving you more money. Like that's what compounding interest means. Sometimes that, like usually it happens at the end of the month, but it depends on where your money is and what type of account it's in. It might just happen at the end of the year. It could happen like a couple of times throughout the year. Like my girls, we have like money in a college fund, which maybe your parents have money in a college fund for them as well. So I get a quarterly statement that shows me the extra amount at the end of that quarter that was added into their account just because they're investing it and earning interest on it. So that's what like interest does. It gives you money, or the other way around. When I go to buy a car, I have to pay interest because I'm now borrowing money from a bank to have a car. And so then I am paying them, and that's every single month. So at the end of the month, whatever money I owe on the car is then calculated and extra interest is added into it. So even though I paid something off, there's still extra money continually being added to that until it breaks down to a pretty small number. So interest can be good because you can earn money, but interest is also bad because then you have to pay the bank extra money. But compounding it means that time where the interest is calculated into the amount that you owe or the amount the bank owes you. So in these two formulas, the key thing to look at is the way it's compounded. If it says it's compounded yearly, quarterly, daily, annually, we use the first formula. If it says continuously, which literally means every single millisecond that you can think of, essentially like infinitely times a day, you're earning money on an account. So that would give you the most amount of money because the more times it's compounded, the more money you're earning. That's the formula, like these two formulas is how we created the number E last year. So that first formula helped us create the number E for the second formula. But the first problem here, I consider these plug and chug problems because they don't really require a lot of thought. It's just reading through the problem and kind of thinking about what the number represents and where it goes in our formula. A total of $12,000 is invested at an annual rate of 9%. Find the balance after 5 years if the interest is compounded quarterly. So that's the key word because that determines whether you're using Formula 1 or Formula 2. So Libby, if it's compounded quarterly, how many times a year is it compounded?
4 times.
4 times. So since she said 4 times, that means we have to apply the information into the first formula. So Libby, the $12,000 represents P, yeah. Principal is the amount that you are investing or the amount that you're borrowing for a loan. So that's $12,000. And then the rate as a decimal, Libby, so our rate was 9%, but as a decimal it is
0.09.
right, 0.09. And then we're dividing that by n, which she said was 4. So that 0.09 is for the whole year, but we're dividing that in 4s because it's going to happen 4 separate times throughout the year. And then you're taking n, the number of times, which is 4, times t, because it's 5 years. So really, you are earning interest 20 times throughout that 5-year period. So that's what that actually means. So you plugged it in. Brandon, now you can let your calculator chug its way through the problem to get an answer
Already on it,
of,
not done yet.
oh, you just said you had it, Chelsea.
18,726.11.
26. 26, there we go. So you have really nice grandpa who's wealthy. Some grandpas are wealthy, grandmas are wealthy. And when you turned maybe 12, 13, they're like, hey, I'm going to give you $12,000 for your birthday, but I'm not going to give it to you now. I'm going to invest it in the stock market because it's looking really good and it's earning a lot of money. And then when you turn 18 and go to college, I'm going to give you that $12,000 and whatever you earned on it. Well, now Grandpa's giving you $18,726, even though he invested $12,000. You now earned money on that account. So that's what that's doing for you. You're earning money. Everybody wishes they had a really nice grandpa like that, or grandma. So the next question, similar, kind of worded just slightly differently. How much money should be invested at 8.5% compounded continuously? So there's our important word. The way it's compounded, in order to produce a final balance of $100,000 after 25 years. So this would be like the day you're born. Somebody's going to calculate this and be like, all right, in 25 years for your 25th birthday, even though you're born, we want to give you $100,000. How much should I invest now so that when you're 25, I can give you $100,000? That's the kind of question that this is like talking about.
That's a really nice grant.
Yeah, that would be an awesome graph. So compounded continuously means we're using the PERT formula. That key word there is continuously, so we need to use the other formula. So what are we plugging in here? Chelsea?
For A, you plug in 100,000.
Yeah, so we don't know what the principal is, the amount we want to invest. That's what we're trying to figure out because our end result is $100,000. And then Chelsea, the rate, if it's 8.5%, is really?
0.085.
And the number of years would be 25. It'd be a really nice 25th birthday present. So to get P by itself, we have to take this E to the 0.085 times 25. Again, don't round. Take that whole number. So we're taking 100,000 divided by E to the 0.085 times 25. Do you guys know where the second answer button is on your calculator? mine shows up. Oh, it does. So if you have like a whole answer that you want to use in your calculator and it says not to round, if you use second and then the minus sign, it pulls in like that previous answer into your problem. Mine's not doing it because it's the spinning wheel. But second and then the minus sign will take like that whole answer. So if you want to calculate e to the 0.085 times 25, and then it shows up like this. So it's like pulling your entire answer from the previous step that you just calculated into the next step of your calculator. So Jenna, how much money should be invested? Oh, she says I didn't put it in my calculator. She doesn't have her calculator on desk because we don't use it very much. Brandon?
$11,943.30.
So again, almost $12,000, but 25 years later, you'll have $100,000. It should be a really nice grandpa.
That's a really nice bag.
Yeah. A couple of years of college right there. Questions? So those would be our interest formulas. The other thing that we can kind of try and work on, besides just random word problem applications, is to create an equation when you're given a set of ordered pairs. We've done equations for parabolas when you have a vertex and an ordered pair. We've created equations of lines when you have 2 points and you're finding the slope of the y-intercept. So we can always create equations when you're given points on a graph. And then using that equation will enable us to find out other information and kind of evaluate what the equation is doing. So this one says find an exponential growth equation based off of the fact that the graph passes through the point 0,5 and 4, 1. So we're trying to create an equation to match those 2 points. How would you do that? Virginia? Put 5 and 4? Why? So this is our initial amount. And she said to plug it in for A. And just to kind of see like why you're plugging it in for A. Virginia, the 0 and 5 represent which letters? Any point represents what letters? X and Y. So if you have the point 0,5, that really represents X and Y. So if you plug that into this equation for X and Y is 5, we don't know A, E is a number, we don't know B, but X is 0. Virginia, what happens with this E to the B times 0? That becomes 1. So that's why A is equal to 5. The initial amount is equal to 5 because when you have an y-intercept, your x value is 0. And when you have any number to the 0 power, it's equal to 1. So that initial amount is 5. So as she said, you would let A be 5. So now we have 5e to the bx. That's our initial amount. And then Virginia, what do you do? Yeah, so then you plug in the next point for x and y. So 1 is equal to 5, that was A. We don't know B, but x is 4. And then you have to solve. So we would want to get rid of the 5, divide the 5 out, that gives us 1/5 e to the 4b. So we're finding b, we're not finding x, we're not finding y, because we have x and y, we're actually finding b. And Sabrina, in order to get b, what do you have to do?
Do you turn it into the logarithmic thing?
So the natural log of,
It's natural log of 1/5 is equal to 4b.
so in your calculator, you'd plug in the natural log of 1/5, and then we need to divide that by 4 to get the value for b. So A, what's the initial amount? We now found B by using that initial amount and the second ordered pair. And Sabrina, what is that B value?
Becomes negative 0.402.
So it said write an equation. Our equation would be y equals 5 that's the A value, E, and then negative 0.402x. So if you choose to do the toad problem, the cane toad problem, you would use this process here to come up with the equation, and that's one of the things it does ask you to do. So it does ask you to do a little bit of math. So you would have to create ordered pairs, and then come up with an equation that represents the information given for the number of cane toads in Australia. So your homework tonight, there are a handful of problems in the book that are application problems. So there's a couple of problems involving the PERT or the compounded interest formula. Then there's just a couple of word problems. The formula might be given, but you're asked to kind of find out when time is a value. Or like the problem we started the class with, you're asked to find out when an amount is left, how long does that take to happen. The other worksheet that I'm passing out to you is just a little review about logs and exponent equations. The answers are on the back. And then again, tomorrow we will work on an application page with a partner or in a small group. Friday we'll review for your test on